Hi, welcome to day 2 of related rates. Today we're going to talk more about right triangles, and we're going to hit a little bit more on similar triangles later on. So, Luke is fishing for ewoks on top of a 16-foot tower. Upon catching one, he reels it in at a rate of 2 feet per second. Now, question A, there are some questions here we have to fix. At what rate is the ewok moving when there is 20 feet of line out? Okay, so I'm going to first draw a picture. First, I'm going to draw Luke on top of a tower. Here's my tower, and there's the ground. So Luke is standing on top of a tower. He catches an ewok. Here's my ewok, short, fat, and hairy. He catches my ewok, and upon reeling it in at 20 feet per 2 feet per second, he wants to know how fast the ewok is moving towards the tower, basically. So now if you kind of notice, if you use your imagination, this is basically a right triangle. So I'm going to call this A, this B, and this C. Now we're told C is 20, so there's 20 feet of line out. And we're told A is 16 because that's how long the tower, that's how tall the tower is. So using the Pythagorean theorem, if we do like 16 squared plus B squared equals 20 squared, we get B is 12. So I know that length is going to be 12 here. So what they're asking me to find, they've given me dc dt. That's how fast we're moving. And it's going to be a negative 2 feet per second. It's negative because the distance is being shortened. So it's a shortened distance. As the ewok is moving closer, the distance is getting shorter. So the negative there tells me that the ewok is heading towards the tower. So we got dc dt, and they also, not directly, but they tell me dA dt as well. Now dA dt is a constant. So that's not going to change. It's going to be 0 feet per second. And what they want me to find here is how fast the ewok is moving. dB dt. So what I need is an equation that has right triangles, the letters A, B, and C. Pythagorean theorem. A squared plus B squared equals C squared. Now, remember, kind of the rule is, if it's a constant, and you know it's a constant, you can just replace it. So I could just write this as 16 squared plus B squared equals C squared. Because the kind of the rule is, here's kind of the rule, if it changes, give it a variable. If it changes, it gets a variable. In other words, as the ewok is moving, this distance is changing. So I'm going to keep it as B, even in the equation. As the ewok is moving toward the tower, the length of the line is also going to be changing. So I keep that in terms of C. But the height of the tower never changes, so I keep it at 16. And that's nice because when I take the derivative, it's just 0. Right? So then I keep taking the derivative. This becomes 2b dB dt equals 2c dc dt. And now I can just plug in everything. 2b, we said was 12. dB dt is what I wanted. 2c we know is 20, and dc dt is negative 2. So dB dt equals, this becomes, what's that, negative 80 over 24, and that's going to be feet, because units is feet per second. Now, what does the negative tell me? That the ewok is heading towards the tower. So we can say this, that the ewok is headed towards the tower at a rate of, ran out of room, 80 over 24 feet per second. I know I ran out of room there. There we go. So basically we're saying that the ewok heads towards the tower at a rate of 80 over 24 feet per second. That's what negative means. If it was positive, he'd be moving away. Now the next question, part B, is kind of a big one, at least in the AP, is the change of angle. So we're going to talk about that. We're going to spend some time with change of angle problems. These are kind of big for us, okay? I do like them, so you'll see them again. It says, at what rate is the angle between the line and the ground changing? So if I draw this picture again, now I'm just going to use the right triangle this time. We have A, which we know is 16, B is 12, C is 20. but I want the angle between the line and the ground. There's the line. There's the ground. There's my angle, theta. We're looking for at what rate is the angle between the line and the ground changing when there's 20 feet of line. So we are asked to find here d theta dt. Now, here's the thing about trigs, about thetas. When dealing with theta, it means we have to use a trig function. Okay? Now we are in luck because this is a right triangle. Now, any trig function will work. I can use sine of theta. I can use cosine of theta, tangent theta. Okay? Any trig function will work. But here's my hint. With trig functions, here's the hint. Pick one that involves a constant. Makes it much easier for us. Involves a constant. In other words, which value over here, A, B, or C, is a constant? Yeah, that length is never changing. Okay? So this is my opposite side, so I can use tangent, or I could use sine. So I'm going to use sine because I know the hypotenuse is changing at a nice value. Okay? So I'm going to use sine of theta in this case. So I'm going to use sine of theta because A is constant. So what that means is I'm going to write this as sine of theta equals the opposite over the hypotenuse, A over C, but remember, that's a constant value. So what does that mean I can do? I can replace that. Sine of theta equals 16 over C. Now I'm ready for the derivative. The derivative of sine of theta, be careful, it's implicit, right? There's a parenthesis there, is cosine theta d theta dt. That's the part most people tend to forget, the d theta dt. Equals, now that's a hard derivative to take. Most of us should remember that's just 16c to the negative 1. So I'm going to get negative 16, that becomes c to the negative 2 over c squared. But again, it's implicit dc dt. And there's my derivative right there. Hardest derivative we take all year long. But now I can plug in. Well, how do I need cosine of theta. So how do I get cosine of theta? Right triangle is just 12 over 20. Sorry, I get the cosine from my right triangle. So this becomes 12 over 20 times d theta dt equals negative 16 over c squared, which is 20 squared, times dc dt. Now dc dt, remember up here we said it was negative 2, so I multiply this by negative 2. And now I can actually kind of solve it. D theta dt equals, this becomes 32 over 400 times 20 over 12. I just kind of simplify that real quickly. And if you reduce that, what you wind up with is 2 over 15. Now, the units are very important. How do we measure change in angle? It's going to be radians per second. And there we go. That's a very big question for us, okay? So if you go to part 2, I'll take a look at a couple more examples. This is my favorite, the shadow problem, and another one, okay? Bye.